Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. Okay, in our first video we have already seen what is limit of a function. So how to check whether limit of a function exists or not using LHL and RHL. So we have seen that concept in first video with basic examples, and in today's video let us solve as many problems as possible and let us see if limit of a function exists or not using LHL and RHL. Okay, we'll start with our first question. Here is our first question. Limit x approaches e, step x is equal to. So where e is a irrational number and it's approximately equal to 2.71, right? So first let us use LHL and RHL. Okay, so LHL is equal to limit x approaches e minus step x. Okay, so you have to understand that x is approaching the irrational number e from the left side. Okay, now so which means step of e minus, and let us take the approximate value of e, which is 2.71 minus. You know that 2.71 minus means what? A number which is just lesser than 2.71. Actually, what is the meaning of 2.71? It means 2.71 minus a value called h, where h is approaching 0 and h is positive real number. Correct or not? You can say that, for example, h is equal to 0.000000 and so on. Which can be 10 power minus 25 or 10 power minus 50 or 10 power minus 100, whatever it is. So it is almost 0.0000 and so on. So you know that 2.71 minus h will also be 2.70 something. Correct or not? And step of 2.70 something, what is it? It is equal to 2. So LHL value is 2. Similarly, let us see what is RHL. RHL is equal to limit x approaches e plus step x. That means step of e plus, which means step of e value is 2.71 plus a number which is 2.71 plus h. 2.71 plus means what? 2.71 plus h. It is also approximately 2.71 only, or 2.71000 and so on. So whose step value is how much, dear students? Step of 2.710 something is again 2 only. So observe that LHL is 2 and RHL is also 2. So LHL is equal to RHL. Therefore the limit of the function exists. The limit of the function exists because LHL is equal to RHL and both are equal to 2. So therefore the limit of this function is 2. Okay, now fine. Let us go with second question. So our second question is limit x approaches 3. This time we are taking an integer. In the first example, I did not take an integer. It was a number e which is not an integer. But in second example, x is approaching integer. Please observe this. Let us see how whether the limit exists or not for step x when x is approaching an integer. For this, once again let us find LHL. LHL is equal to limit x approaches 3 minus step x. So dear students, so step of x is approaching 3 minus, now let us substitute it. 3 minus. Okay, now 3 minus means what, dear students? 2.999 and so on. Correct or not? Somewhere it can have 10 digits after the decimal or 100 digits after the decimal. It doesn't matter, but it is 2.999 something. And step of 2.999 something is equal to 2. So left hand limit is equal to 2. And what about right hand limit? Limit x approaches 3 plus step x, and which means what? Instead of x, let me take 3 plus. And dear students, what is the meaning of 3 plus? 3 plus means 3 plus h. H is 0 point something. Correct or not? So step of 3 point some number, 3.000 and so on, some number, and whose step value will be equal to what? 3. Observe that LHL is 2 and RHL is 3. LHL is not equal to RHL. Therefore, the limit of this particular function does not exist because LHL is not equal to RHL. Okay, so you can generalize this. How do we generalize it? Whenever x is approaching an integer, let me take a number n where n is any integer, n belongs to z, n is any integer. Limit x approaches n, step x does not exist. If x is approaching an integer, then limit x approaches n, step x does not exist. We will go with next example. So here is our next question. Limit x approaches 3, fractional part of x. Here curly braces x or the flower brackets x means what? Fractional part of x. Okay, I hope all of you know that the fractional part of function, fractional part of x is equal to x minus step x. Okay, now that is the definition of a fractional part function. It is equal to x minus step x. For example, if you want to know what is fractional part of 2.9, so x value is 2.9 minus step of 2.9, and it is 2.9 minus step of 2.9 is 2. You'll get 2.9 minus 2, which is 0.9. Or directly, if it is a positive number, we can say that 2 is the integral part and 0.9 is the fractional part. So fractional part of 2.9 is 0.9. So using this definition, we have done that. So let us use the same definition while solving the problem. Okay, now, so fine. Let us see whether the limit of the fractional part of x exists or not when x is approaching an integer called 3. For this, first let me take LHL. Limit x approaches 3 minus fractional part of x. So limit x approaches 3 minus fractional part of x is x minus step x. I have used the definition of fractional part of x. Limit x approaches 3 minus, observe one thing, x minus. First I will substitute x as 3 minus here. And we already have done this. Step of 3 minus is how much? 3 minus means 2.99 something, correct or not? Step of 2.99 something is 2 only, na? Limit x approaches 3 minus. Now instead of x, let us substitute this. What is it? So limit, I am substituting x as 3 minus h. I am taking x is equal to what? 3 minus h. So this is what we do in most of the questions. I will take x is equal to 3 minus h. So when I am taking x is equal to 3 minus h and minus 2 as it is, h is approaching 0. Instead of taking x approaching 0, I will take h approaching 0. Okay, so limit h approaches 0, 3 minus 2 is 1 minus h. Now you can substitute h as 0, and if you substitute h as 0, you will get what? 1. So LHL is 1. So the left hand limit of this particular function is equal to 1. Similarly, let us check what is right hand limit. So in this solution itself, let me find what is RHL instead of LHL. So I am going to find RHL, right hand limit. Then x is approaching 3 plus fractional part of x. And the definition of fractional part of x is x minus step x. X is approaching 3 plus. Okay, now similarly x is approaching 3 plus. So instead of x, we are going to substitute 3 plus. And dear students, 3 plus means what? 3.00 something. 000 something. Okay, now, and step of 3.00 something is how much? It will be 3, and here x is approaching 3 plus, correct? So when x is approaching 3 plus, x is actually equal to 3 plus h. X is actually equal to 3 plus h. I will replace it. Instead of x, I will write 3 plus h minus 3, and h is approaching 0. So plus 3 and minus 3 cancels. So we are getting only h. And instead of h, we are going to substitute 0. When I am substituting 0, our answer is 0. So dear students, the left hand limit is equal to 1 and the right hand limit is equal to 0. Left hand limit is not equal to right hand limit. Since LHL is not equal to RHL, the limit of this function also does not exist. So therefore, you have to remember this once again. This is not just true only for 3. Instead of 3, it can be any number n where that n is integer. Limit x approaches n, fractional part of x does not exist if that number n is integer. Are you understanding this? Where n is integer. So remember this. So it is true for fractional part of x and it is also true for step x. We might be using these results in some other problems. Okay, we'll go with next question. So our fourth question, limit x is approaching 4, mod of x minus 4 divided by x minus 4. We have to check whether the limit exists or not. So once again, let us go for LHL and RHL. So left hand limit is equal to limit x approaches 4 minus mod of x minus 4 by x minus 4. Please observe how to solve modulus function is very important. You have to understand its properties. First of all, x is approaching 4 minus means what? X is less than 4 only. The value of x. X is approaching 4 minus means x is 3.99 something. X value is 3.99 something, which is less than 4. X is less than 4 means what? Take 4 left side. X minus 4 is less than 0. X minus 4 is inside this modulus and it is negative value. So according to the properties of modulus, then mod of x minus 4 will be equal to minus of x minus 4. If x minus 4 is less than 0, then modulus of this will be negative of it according to properties of modulus. It is important to understand modulus functions. What if x minus 4 is greater than 0? If you get greater than 0 here, I'll write plus. And if it is less than 0, I'll keep minus. Okay now, so come to this question. Limit x approaches 4 minus, and instead of mod of x minus 4, we are writing minus of x minus 4. Denominator as it is. So these two will get cancelled. We are getting minus 1 as answer. The left hand limit is, dear students, minus 1. Similarly, let us see what is RHL, the right hand limit. So RHL is equal to limit x approaches 4 plus mod of x minus 4 by x minus 4. So once again, dear students, let us try to understand how to replace mod of x minus 4 with other function. How do we do that? X is approaching 4 plus means x is greater than 4 only. Na? X approaches 4 plus means what? X is equal to 4 point something. X is equal to 4 point something means that x value is more than 4 only. That means take 4 left side, x minus 4 is greater than 0. X minus 4 is greater than 0 means mod of x minus 4 will be equal to plus of x minus 4. And if x minus 4 is less than 0, we got minus sign. If it is greater than 0, we got plus sign. You have to understand the properties of modulus. So it is equal to what? Limit x approaches 4 plus, and instead of mod of x minus 4, we are writing x minus 4. Denominator as it is. So these two will get cancelled and you will get 1. RHL is 1, but LHL is minus 1. LHL is not equal to RHL. So therefore, dear students, limit of this function also does not exist because left hand limit is not equal to right hand limit. Okay. So we'll go with next example. But before going to next example, I'll give you one question. You can try it. So here is a question that you can try. Okay now. So you can take LHL, you can find the answer, and you can take RHL and you can find the answer. But remember one thing, in LHL you will get x approaches 0 minus. It means x is less than 0. And when x is less than 0, you should understand that mod x is minus x. Inside the modulus, whatever is there, if it is negative, when I remove modulus, I have to keep minus sign. Okay now, similarly, in RHL, when x approaches 0 plus, it means x is greater than 0, and therefore mod x will be equal to plus x. Because x is positive, inside the modulus we have a positive number. So when I remove modulus, I'll keep plus sign. Okay now, so you can use this while solving LHL and RHL. If LHL is equal to RHL, you can write that answer. If LHL is not equal to RHL, then limit does not exist. So you can try this question and let me know in comment sections if you have got the answer or not. But this is very easy question. Okay, we'll go with next question. So question number 6. Limit x approaches 0, 1 by x. So whether the limit exists or not, let us see. Question number 6. Limit x approaches 0, 1 by x. First, if you take LHL, limit x approaches 0 minus 1 by x. And dear students, we know that x approaches 0 minus means what? X is equal to 0 minus h only, na? Which means x is equal to minus h. And we take h approaches 0. Correct? So it is equal to limit. Instead of writing x approaches 0 minus, we are writing h approaches 0 and 1 divided by, instead of x, we are going to substitute minus h. So limit h approaches 0 minus 1 by h. Okay, fine. And when h is approaching 0, 1 by h is approaching infinity. Correct or not? If you try to substitute 0.0000 and so on, 1 by 0.0000 and so on is infinitely larger number. Or simply to say 1 by 0 looks like infinity only. It is not. It is actually not defined. Which one? 1 by 0 is not defined. But here h is not 0. H is only approaching 0. H is approaching 0 means h value is 0.000000 and so on. this number is trying to become infinitely larger number. So minus as it is. So when h is approaching 0, 1 by h is approaching infinity. So therefore, dear students, LHL is equal to minus infinity. And yes, left hand limit or right hand limit can approach plus infinity or minus infinity. And one more important thing is, when I'm writing LHL is equal to minus infinity, I'm not actually saying it is equal to minus infinity. We are trying to say that when x is approaching 0 from the left side, 1 by x is approaching minus infinity. That is what we are trying to say. Same way, dear students, what is RHL? RHL is equal to limit x approaches 0 plus 1 by x. X approaches 0 plus 1 by x. Same way, x approaches 0 plus means x is equal to 0 plus h. Correct or not? And h is approaching 0. So therefore, it is equal to limit. Instead of writing x approaches 0 plus, I am writing h approaches 0. 1 divided by. Instead of x, we are writing h. And dear students, when h is approaching 0, h is approaching 0. 1 divided by 0.0000 and so on. It is infinity. Correct or not? Plus infinity. When h is approaching 0, then 1 by h approaches infinity. So please observe one thing. The left hand limit is minus infinity and the right hand limit is plus infinity. And left hand limit is not equal to right hand limit. Therefore, dear students, limit x approaches 0, 1 by x does not exist. Does not exist. Okay now. So next, and I just wanted to give you a clarity about this particular function if its graph is given. So let me draw the graph of 1 by x. It will give you more clarity. Okay now. And remember, left hand limit is minus infinity and right hand limit is plus infinity. Let us see the graph of 1 by x on the graph paper. It will give us more clarity about left hand limit and right hand limit when x approaches 0. So this is the graph of y is equal to 1 by x. So if you know how to draw the graphs now, it is really an added advantage to understand limits concept. If you observe here, when our input is approaching 0 from the right side, the output is approaching what number? Plus infinity. So as x is approaching 0 from the right side, output is approaching plus infinity. The figure says now, when input is approaching 0 from the right side, the output is approaching plus infinity. Similarly, when x is approaching 0 from the left side, you can understand. When input is approaching 0 from the left side, then the output is approaching what? When input is becoming 0 from the left side, output is becoming minus infinity from the minus infinity. So y is approaching minus infinity. Even graph also says that at 0, towards the right side it is going to plus infinity and towards the left side it is going to minus infinity. LHL is not equal to RHL. The limit of this function does not exist. So let us see a similar function of 1 by x. And that similar function is what? Limit x approaches 0, 1 by mod x. See what happens in this question if I find LHL and RHL. So left hand limit is equal to limit x approaches 0 minus 1 by mod x. Right? So as x approaches 0 minus means x is equal to 0 minus h, where h is approaching 0. So in the next step, I'll write what? Limit h approaches 0, 1 divided by modulus of, instead of x, we will write minus h. And dear students, h is a positive number. So minus h is a negative number. So which is equal to limit h approaches 0, 1 by modulus of negative number is positive number only. Na? So modulus of minus h is plus h. So and already in the previous question I have discussed, when h approaches 0, 1 by h approaches infinity, plus infinity. Similarly, what is RHL? Right hand limit? Limit x approaches 0 plus 1 by mod x. So x approaches 0 plus means x is equal to 0 plus h, where h is approaching 0. So limit h approaches 0, 1 divided by mod of, instead of x we are writing h. And 1 by mod h, h is already positive number, it does not need modulus. So limit h approaches 0, 1 by mod h is equal to h. Here also h approaches 0, 1 by h approaches infinity. So LHL is plus infinity, RHL is also plus infinity. LHL is equal to RH So both are equal to plus infinity. So therefore, what is the answer in this question, dear students? When x approaches 0, 1 by mod x is approaching infinity. From left side also it is approaching infinity. From right side also it approaches infinity. Can you draw the graph of 1 by mod x? I have drawn the graph of 1 by x. Can you draw the graph of 1 by mod x and can you check it once? Whether from the left side also the graph is going to plus infinity or not. From the right side also the graph is going to plus infinity or not. You can try it once. Give it a try. You may get the correct graph or you may not. But at least you are trying to learn something. Right? That's important. Fine. We'll go with the next concept. A small concept which is important to understand. What is that small concept means, dear students? Remember it. You take a proper fraction. Proper fraction power infinity will be equal to 0. How do we use it? For example, 1 by 2 power infinity is equal to what? 0. Actually, it is not infinity. It is a number very close to infinity. Okay, now, or 2 by 3 power infinity is equal to 0. Or 3 by 2 power minus infinity. If I want to convert negative power into positive power, then we have to take the reciprocal of the base, correct? Which means 2 by 3. When 3 by 2 becomes 2 by 3, power minus infinity becomes plus infinity. And proper fraction power infinity is equal to 0. Okay, now, so you have to remember this. What we have to remember? Proper fraction power infinity is equal to 0. Y actually means you can draw the graph of a power x and you can check it once. Okay, now where the base a is between 0 and 1. What I'm trying to say is, if a is between 0 and 1, then a is proper fraction, correct or not? Then limit x approaches infinity, a power x is equal to. Once again, what is it? A is between 0 and 1. So a is a proper fraction power and x is approaching infinity. So proper fraction power infinity will be equal to what? 0. Same way, dear students, when a is greater than 1, that means what? A is a improper fraction. When a is what fraction? Improper fraction. Then limit x approaches infinity, or limit approaches infinity, a power minus x will be equal to 0. Remember this. If it is improper fraction, if the base is improper fraction, then the power should be minus infinity. Improper fraction power minus infinity is equal to 0. So improper fraction power minus infinity should be equal to 0. For example, pi, whose approximate value is 3.14. Pi power minus infinity will be equal to 0. Or irrational number e power minus infinity will be equal to 0. Okay, now, so once again I'm saying proper fraction power infinity is 0 and improper fraction power minus infinity is 0. Remember this, I'll be using it to solve the upcoming questions. Here is our next question. Limit x approaches 0, e power 1 by x divided by 1 plus e power 1 by x. In this question also we have to check LHL and RHL. Why we have to check means, in the previous question we have observed that when x approaches 0 from the left side, e power, what is it? 1 by x, not e power. When x is approaching 0 from the left side, 1 by x is minus infinity. And when x is approaching 0 from the right side, 1 by x is plus infinity. It is varying in the LHL and RHL. So we must take LHL and RHL and we have to check whether LHL and RHL are equal or different. Okay, now, so please observe this. Once again I'm saying why we are taking LHL and RHL in this question, because of the presence of 1 by x and since x is approaching 0. Okay, now, so let me take LHL. Limit x approaches 0 minus e power 1 by x divided by 1 plus e power 1 by x. Understand one thing, dear students. E power, the base is an improper fraction. So when the base is improper fraction, you do something and you make sure that the power is minus infinity. Are you understanding this? The power is what? Minus infinity. Okay, anyhow, when x is approaching 0 from the left side, we have already learned that 1 by x is approaching minus infinity in the previous example, correct or not? And at the same time, e power 1 by x means what? E power minus infinity. And what is e power minus infinity? 0. So dear students, instead of e power 1 by x, what number we can substitute? 0. So directly we can substitute 0 by 1 plus 0 and the answer is 0. Once again I am saying, when x is approaching 0 from the left side, 1 by x is approaching minus infinity. We discussed it in the previous question. So 1 by x is approaching minus infinity. So what happens to e power 1 by x? 1 by x is approaching minus infinity and e power minus infinity is 0. So therefore instead of e power 1 by x, we are taking 0. Instead of e power 1 by x, we are taking 0. I substituted, I got the answer as 0. Now let us see how to solve this in RHL. So RHL, right? As I told you before, if the base is improper fraction, the power should be minus infinity. Then e power minus infinity can be taken as 0. But here x is approaching 0 from the right side. And what happens to 1 by x? 1 by x will be approaching plus infinity. Then what are we getting here? E power infinity. We are getting e power infinity as infinity. No, we cannot do it like this. I want e power minus infinity. So what I will do in this particular question means divide the numerator and denominator with e power 1 by x. So observe this. This is what I am going to do. You should remember this. So divide the numerator with e power 1 by x and the denominator also with e power 1 by x. Then what happens, dear students? So limit x approaches 0 plus the numerator is going to be 1 by e power 1 by x is e power minus 1 by x plus this by this is again 1. And dear students, when x is approaching 0 plus 1 by x is approaching infinity. If 1 by x is approaching infinity, then minus 1 by x approaches minus infinity only. Na? 1 divided by e power. If 1 by x approaches infinity, minus 1 by x approaches minus infinity. And what is the value of e power minus infinity? Improper fraction minus infinity, 0. So then what is the answer? 1 divided by 0 plus 1. I am getting 1. Right hand limit is 1. Left hand limit is 0. Right hand limit is 1. LHL is not equal to RHL. Therefore, limit of this particular function does not exist. You will get more clarity about the way I solved here in the next question. In the next question also same thing only, dear students. 8th question and 9th question are very, very important. Keep this in mind. Okay, now. So fine, we'll go with the next question, 9th question. So here is our 9th question. Limit x approaches 0, this by this. Okay, now it contains e power 1 by x and at the same time it contains e power minus 1 by x. So understand one thing. If it is improper fraction, then the power should only be minus infinity. You have to keep this in mind. If the base is improper fraction, e 2.71 improper fraction approximate. Okay, if the base is improper fraction, then the power should be minus infinity. Keep this in mind. So if that is the case, when x is approaching 0 from the left side, 1 by x is approaching minus infinity. We discussed it in the 7th example. 1 by x is approaching minus infinity, then e power 1 by x is approaching e power minus infinity, which is 0. So e power 1 by x can be taken as 0. What about e power minus 1 by x? If 1 by x is approaching minus infinity, then minus 1 by x is approaching infinity. But e power infinity is not 0, it is infinity. So when I am taking LHL, understand one thing. The LHL must contain only e power 1 by x. It should not contain e power minus 1 by x. Keep this in mind. Because e power 1 by x is becoming 0. Happy, I can keep it. But e power minus 1 by x is approaching e power infinity, which is infinity. I should not have e power minus 1 by x when I am solving LHL. So dear students, what I am going to do is, while solving LHL, e power 1 by x will be there and I should do something and I should eliminate e power minus 1 by x. So what shall I do? Divide numerator and denominator with e power minus 1 by x while solving LHL. Okay, let us see LHL. So as I discussed already, when x is approaching 0 from the left side, 1 by x is approaching minus infinity and e power 1 by x is approaching 0. E power 1 by x only should be there. So what I will do is divide the numerator and denominator with e power minus 1 by x. Do something and make sure that e power minus 1 by x is not there in the function. Then what happens, dear students? Limit e power 1 by x approaches 0. What is it? E power a power m divided by a power n. A power m minus n only. No? So m minus n is 2 by x. And this is 1. Again here also e power 2 by x plus 1. Dear students, if e power 1 by x approaches 0, then do squaring. E power 2 by x also approaches 0 only. Na? So e power 2 by x is 0, minus 1 by 0 plus 1. So minus 1 by plus 1 is minus 1. Therefore the left hand limit in this question is what? LHL. The left hand limit LHL is equal to minus 1. Remember this? We got LHL equal to minus 1. Okay, now we got LHL is equal to minus 1. Same way, I think you understood how to solve RHL. If you got the idea, pause the video and find RHL and then check whether you got the same answer or not. You might have understood now how to solve RHL. Okay. Yes, as we have learned already, when x is approaching 0 from the right side, 1 by x is approaching infinity. But the base is improper fraction, and if the power is infinity, e power infinity is infinity. We cannot help out. But if e power must be what? Minus infinity. Okay, now when 1 by x is approaching infinity, then minus 1 by x is approaching minus infinity. And e power minus 1 by x means what, dear students? E power minus infinity, which is becoming 0. So in this particular question, what should be there? E power minus 1 by x should be there. And what should not be there? You know very well. E power 1 by x should not be there, because e power 1 by x is approaching e power infinity, which is infinity. We should not have e power 1 by x. So with what shall I divide in numerator and denominator? Obviously you should have understood. Divide the numerator and denominator with e power 1 by x, because you don't want what? E power 1 by x. So what happens then? Limit x approaches 0 plus, here you will get 1 minus. Once again, a power m divided by a power n is a power m minus n. You will get e power minus 2 by x. In the denominator also, I'm sorry, this is plus. Okay, 1 plus e power minus 2 by x. And dear students, if e power minus 1 by x is approaching 0, if e power minus 1 by x is approaching 0, then you can do squaring on both sides. E power minus 2 by x is also approaching 0. It's not actually squaring on both sides. If e power minus 1 by x is approaching 0, then its square is also approaching 0. So therefore, it is equal to what? 1 minus, this is 0, divided by 1 plus 0. And the answer is 1. RHL is 1, but LHL is minus 1. LHL is not equal to RHL. Left hand limit is not equal to right hand limit. Therefore, the limit of this function also does not exist. Okay, now, so we have seen some basic questions and we have found its LHL and we have found its RHL. If left hand limit is equal to right hand limit, we said that limit existed. And if they are not equal, we said that the limit does not exist. Correct or not? So these are some basic questions on existence of limits. In this video, we have seen basic questions. In next video, let us collect even more questions. Not basic questions, but where you have to think. Okay, now think well and you have to answer. So in the next video, let us collect the remaining models on existence of limits. Okay, now, so see you all in the next video, and I hope you have understood limits better after listening my class. If that is the case, do like the video, share it with your friends, and subscribe the channel if you are new to the channel. And thank you. This is Sandeep Kumar. See you all in the next video. Thank you.